Okay, gang. So far we haven't been really doing that much chemistry, right? It's just been a lot of, here's a sugar in this formation, this conformation, view. Let's kind of transfer into this one, right? Whether it's Fisher to Haworth, or, flat line to chair to Haworth, you know what I mean? You can go from any one conformation to another. So in this video, let's kind of get back to our roots a little bit. Let's do a little bit of chemistry. Kind of similar to the video where we formed the hemiacid tau. Okay, so what I'm going to show you guys is from 3, 4, 5 carbon sugars, we can lengthen our chain by 1 carbon through this reaction. Okay, so I'm just going to make up some sugar. Doesn't matter too much what it is, so much as what happens to the aldehyde in the sugar. Okay, so 2, 3, 4, 5. Yeah, let's do a 5. Carbon sugar. Just make up wedge, dash, and why not another dash? Okay, given this sugar, we can lengthen the carbon number in this chain by 1 if we can do the following reaction. If you use hydrocyanic acid as well as a reducing agent called diisobutyl aluminum hydride, basically what this is just a mild source of H-, not as strong as LAH. If we use HCN and diisobutyl aluminum hydride, what we can do is we can actually lengthen this carbon chain by 1. And I'm just going to show you the brief mechanism. And the best part is, you guys already know it. So here's what's going to happen. Right, we have a carbonyl. Right, we have a source of acid. Right, we have H+ and Cn- technically. Right, so what's going to happen, I'm going to expand this, is this oxygen, he sees the H of the acid, right? He's going to grab H+, or electrons get dumped off on the carbon inside what will be cyanide ion, right? I'm going to draw an arrow down here. H2COH dash dash. We have oxygen with a plus charge now. And remember, we've now activated our carbonyl. He's trigonal planar and flat. He's perfect for attack, right? For some SN2. Right? Now we have Cn-. So what we will do is Cn-, this carbon's going to come in. He sees the partially positive carbon in the carbonyl, and he's going to attack, right? And electrons will kick up onto oxygen. And remember, he's trigonal planar and flat, so attack will happen equally on top and on bottom, right? A racemic mixture will result. HO, H2C. Sorry, just drawing the rest of the structure. Wasn't even a part of the chemistry. Okay, so I'm not going to draw this carbon explicitly anymore. I'm going to draw a squiggle OH, remember, because attack happens on top and on bottom equally. So this is going to be a wedge and a dash, 50%, 50%, right? Now, I'm going to draw this line, right? And now we have Cn. Okay, cool. So, what's going to happen here is from this step forward, we reduce the nitrile to what will be an aldehyde. So in this step, I'm going to kind of skip it a little bit. I don't think you necessarily need to know it. It involves going through an imine, stuff you guys already know. What happens is this diisobutyl aluminum hydride takes the nitrile to an aldehyde, and you'll see what that does for us when I draw it out. Squiggly. And I'll make it even more clear by drawing this carbon. You see what we did? As a result, right, we had this carbon as an aldehyde, and by attacking and then reducing the nitrile to an aldehyde through this reducing agent, all we've done is lengthen our chain by 1 carbon, right? And this was something you already knew how to do, right? It was protonate the oxygen in the carbonyl, take the conjugate base from that, and attack. It happens to be CN minus. Remember, this is a squiggly line because trigonoplanar and flat, attack happens on top and bottom equally, right? And then what you do is you take the nitrile, and with this reducing agent, then recover an aldehyde, and now realize you have an aldehyde and an alcohol on bottom. This is a sugar we're used to seeing. So you can do this from starting with a thing with 3 carbons in a sugar and going to 4, 4 carbons to 5, 5 carbons to 6, right? So now you can see how you can kind of grow small building blocks, small sugars, into bigger sugars, right?